So previously, we were trying to compute the cohomology of the G-hole torus. Our plan is to use induction via the Meyer-Torus sequence. So we use the following covering of the G-hole torus. We take U to be the punctured G-1 hole torus, right? And then V to be the punctured torus. In that case, that intersection is just going to be homotopic to the circle. Because U, V, and U intersect with V were all connected, so we can start the long exact sequence at 0. And then we have proven that this map here is just 0. So then we have H1 of the G-hole torus is just going to be isomorphic to this direct sum. Thus now, to compute this cohomology of the G-hole torus, we need to compute the cohomology of the punctured G-hole torus. And thus, that's what we're gonna do next. We're gonna show that this is gonna be 0, right? This is gonna be 0. And then for H1, we're gonna show that taking out a point, right, puncturing the G-1 hole torus does not change its H1 cohomology. So then we get this is gonna be isomorphic to H1 of the G-1 hole torus, and so we can use induction hypothesis. Alright, so let's prove that. Let's compute the cohomology groups of the punctured G-hole torus. As usual, we're gonna use the Meyer-Torus sequence. So we're gonna cover the G-hole torus by the punctured G-hole torus together with this open set U. Now observe that the intersection of this punctured G-hole torus with the open set U is just homotopic to the circle. In particular, this punctured G-hole torus, the open set U, and their intersection are all connected, so we can start this long exact sequence with 0 here. Now this disk U is just homotopic to a point, so H1 and H2 are both 0. Moreover, from our previous discussion, we know that this pullback map, right, from the first cohomology of the punctured torus to S1, that map is just trivial, it's 0. So by exactness, we have this isomorphism here. Thus, we've shown that puncturing the G-hole torus does not change its H1 cohomology. Now next, observe that by exactness here, we must have that kernel of this map is equal to image of this map, which is 0. So this map here is injective. So if we have that this H2, right, H2 of sigma G is isomorphic to R, then this is an isomorphism, so this must be 0. Thus we conclude that H2 of this punctured G-hole torus must be 0 if H2 of the G-hole torus is isomorphic to R.